Okay, now we're going to take a look at example 18, which is actually like a couple of different things all at once, and then they skip something which we touched on but we should go back to. Let's start with some functions f, g, and h. Okay, the first thing you should notice is for f, g, and h, they are all permutations. That is, the domain and the range are the same set, and they are bijective. All right, let's go ahead and move those out of the way a little bit. Now, before we said the associative law was true, right? H of g of f is the same as h of g of f. Let's go ahead and show that with an example here, as long as we're all here. So g of f is going to be 1, 2, 3, 4, 5. 1 for g, that gets 2. When we input that into f, that gets us 1. So 1 to 1. 2 of g gets us 3, which gets us 4. 3 goes to 4, which goes to 5. So g of f is this function right here. And if we do h of this function, well, we have 1, 2, 3, 4, 5. 1 goes to 5, which we can see from here goes to 2. 2 goes to 4, which goes to 3. 3 goes to 2, which goes to 4. 4 goes to 1, which goes to 1. And 5 goes to 3, which goes to 5. So this is h of g of f, right? If we do it the other way, h of g, 1, 2, 3, 4, 5. 1 goes to 5, which goes to 1. 2 goes to 4, which goes to 5. 3 goes to 2, which goes to 3. 4 goes to 1, which goes to 2. And 5 goes to 3, which goes to 4. So that is h of g. And h of g of f is going to be, let's draw that over here, 1, 2, 3, 4, 5. 1 goes to 1, which in f goes to 2. 2 goes to 5, which in f goes to 3. 3 goes to 3, which in f goes to 4. 4 goes to 2, which in f goes to 1. And 5 goes to 4, which in f goes to 5. So we see that h of g of f is the same as h of g of f, right? This is evidence of our associative law. We can drop those parentheses, okay? Now, the question is, what about our old friend, the commutative law? That is f of g the same as g of f? Well, let's find out. 1, 2, 3, 4, 5. So, with f of g, 1 goes to 2, which goes to 3. 2 goes to 1, which goes to 2. 3 goes to 4, which goes to 5. 4 goes to 5, which goes to 1. And 5 goes to 3, which goes to 4. So that is f of g. If we do g of f, 1 goes to 2, which goes to 1. Now already we can see this is not the same as f of g. But I'm going to go ahead and finish this out, and you can follow along. So we can see that f of g does not equal g of f. There is no commutative law for function composition. That's an important thing to remember. Okay, now let's do a few powers. Remember, powers, if we say f squared, what we mean is f of f, which means literally, if we do 1, 2, 3, 4, 5, f of f means 1 goes to 2, and then 2 goes to 1. 1 goes to 1. I should put parentheses on here. 2 goes to 1, and 1 goes to 2. so we get 2. 3 goes to 4, 4 goes to 5, so I get 5. 4 goes to 5, 5 goes to 3, so I get 3. 5 goes to 3, 3 goes to 4, so I get 4. So this is f squared. If I want to do f cubed, which is f of f of f, I essentially take this function here and run it through f again. So again, 1, 2, 3, 4, 5. 1 to 1 of f goes to 2. 2 to 2 of f goes to 1. 3 to 5 of f goes to 3. 4 to 3 of f goes to 4. And 5 to 4 of f goes to 5. So that is f cubed. And then f to the 4th, f to the 5th, you have to continuously keep calculating the power smaller to calculate the next power. And this gets really, really tedious to calculate, really tedious to write, and that's why we have cyclic notation, right, for this type of permutation. And we actually start to talk about cyclic notation and give a really good example of a cycle in example 19. So I'm going to move down to that. If you have any questions about anything here, ask in the forums below.